battle. You want to try them on either end of the table, James?
Maybe we can just set the distance.
Then they're at really different levels. Because the idea is we're going to duel.
Right.
Okay?
Do they have sensors?
So what I'm saying is put both of them on.
They're just going to slash meaningless.
Well, no. It's carefully designed here.
Choreographed.
That's right. All right. So there is a sensor. It's called My Eyes connected to
The RC control.
So so what you guys can see is we've got two Light Sabers here. Well, all right. And we can turn the lights off even.
Yeah, we should.
The lights off over there. And you want to turn yours on too?
I'm on.
No, turn your lightsaber on.
With the so it doesn't have lights.
Aww.
It's a lightsaber.
Light on the.
I think this one is waiting a red LED. So,
the dark saber. Yeah, right.
Don't break it. I think we've
No, it's not the.
okay. So the idea is you can see we're controlling the robot arms with nunchuck controllers, and we can either control them directly by just mapping motions directly to the servos, or there's also some pre-programmed moves.
Hey.
Pretty good pre-programmed move, isn't it? All right. And the idea is it's a game, and I have two badgers and he has two whales, and the idea is for one person to knock the whales of their opponent off while they're trying to get rid of your badgers. Kira, are you ready to come and try this? All right.
Anybody else?
Do we have another person?
I want to do it.
Okay, good. Come on up.
Will somebody take me?
Can I film the...
Yeah, please do.
Are you doing video?
It's on record already.
Okay.
And now you press this button.
This is
Right now it's centered, and this will let you move.
what do I need? Try.
So press and hold this button.
Same with the badger.
And then left, right.
Okay, wait, do we want to get ready, get set, go?
He was already going.
Oh.
Yeah! Oh! One down! Alright.
Now you gotta fight.
Okay.
The animal and knock the other saber onto the floor.
Oh, it's close, that whale is done for. That poor badger. Oh no, that poor badger.
I never was good at video games. Hey, where are you? I'm like in the one. I'm out of range now. How do I get there?
He's almost there, almost there.
All right.
Good job.
So, hopefully, it's more fun when you're working on it and your unsuspecting students are sort of leaning over and you whack them with it. This is a way that you can beat people with swords without consequences.
That's right.
We're going to be showing this at Makerfaire along with a presentation on how to build things with the CM900. Just giving you guys a little bit of an idea about the hardware. There's two CM900 boards here, and I don't know if you guys can see them, but these are these little microcontroller boards we've been talking about that have an ARM M3 processor on them, and they also have an RS-485 bus. And one of the things we did with this particular case is we decided we'd use two different types of servos on two different buses, showing that we can use an RS-485 bus servo and a TTL bus servo at the same time coexisting. I hope you also got to see that there's really pretty nice control. I mean, okay, there's the user problem of control, and there's also the system. But as they were running this and whacking into each other, you guys didn't hear any gears going or things breaking or anything like that. So this is a really nice, robust system. And it took us about, how long have we been working on this, Jinx? Maybe a month?
Maybe 2 weeks, I believe.
Maybe 2 weeks, okay.
Seems like a month.
Yeah, not too much. So it was a pretty easy process to get the nunchucks interfaced to the board.
Yeah, mostly for the nunchuck interfacing was the time.
We had a challenge that we used, first we started off with a nunchuck I happened to have in a drawer, and that worked just fine. And then the library I wrote for that didn't work with the ones we ordered from China. And then I got those working, and then we got more from China that were different. So, just, you know,
All that in 2 weeks, great.
I wrote 3 different I2C libraries in the last month, I think. But the part of this is that it was really easy to put this together, and it's kind of fun. Put things together. I'm also very proud that my daughter helped with the artwork on the base plates. So
It's quite stellar.
she did stellar artwork. So I encourage you guys. These boards are now available. What did the retail price turn out to be, Junice?
20 for the board.
$19.99. $19.99 for the board. So they are available. And it's what's that?
The servos.
The servos have been available for a long time.
Cost.
How much do they cost?
45.
The AX12s are 45. This servo we used came out of their refurb bin. It's not one they sell anymore, so I don't know how much it costs.
Yeah, that's about 200. So
That one's too expensive?
that's the hardest part.
Okay.
Sure, but they're really good.
So this one servo, again, like I said, I've never bought one of these, so I don't know how much they cost. I bought many of these. The other ones we used. Any other questions about the project? Yes.
Why so many servers? Can you do without 3 servers or 4 servers?
You know, we started out with an additional degree of freedom, and we reduced it down to this. What you guys are seeing today is a result of me programming between the hours of 6 p.m. and 1 a.m. last night in terms of the sword movements. I've got one of my students is a LARP Grandmaster. I don't know if you guys know what that means, live action role playing. So he's very excited about designing sword choreography for these robots. So having all the degree gives us full access to the workspace. Right? We want to be able to access every point in this hemisphere, right? And if we reduce the degrees of freedom, that we weren't going to be able to access the whole workspace. Is that fair enough? You're looking a little disbelieving.
I thought you need only 2 servos to pan and tilt, right?
I mean, yeah.
Well, that doesn't make you stay.
It does.
Yeah, point very well.
You can point, but this lets us do sweeping motions, which you can't do with the pan and tilt. Does that make sense? And you can also thrust with this, right? So I can do a thrust in and out, which I can't do with the pan and tilt. So we're trying to be more realistic with our sword fighting, even though it wasn't very realistic just now.
How many servos in each?
There's 4 servos in each one right now. Okay. Yeah. So the reason was wanting to be able to do sweeping slashes and thrust and slashes. I don't know, anybody into kendo or fencing? Oh, then I'm on safe ground. Let me tell you all about it. Oh, okay, sorry.
In college.
Yeah. So you pan and tilt isn't going to do nearly all the saber moves, and neither is this for that matter. But it'll
we
least
could
get
make
close.
a diagonal slash that way.
I think we can do a diagonal slash with this, which we couldn't do with the pan and tilt. Is that fair?
Well, there is very little of the extra movement that you gain by this servo.
It's that I can rotate about this axis while rotating about a slightly offset axis up here that lets me do the arcing slashes. Right? Okay. That's what we wanted. Somebody else, you had a question? Yes.
Yeah, well, so why didn't we hear any gears breaking or anything? Was there something special you did?
Actually, in all these 4 servos, all are using plastic gears. So the only thing I did is I did set acceleration limits on everything so that we're not changing speed too radically. And there's always tuning you can do in that. But the nice thing about having fully closed loop servos is you can set acceleration parameters so you're not over torquing your servos that way.
But when they bang into each other, you're still putting a shock on them.
That's true. But these were also selected to be somewhat flexible. Other question?
Nunchuck, is that analog or digital out?
Oh, excellent question. It's a purely digital output. It communicates over I2C, and I2C is a protocol many of you guys I'm sure are familiar with. We're running at 400 kilobits per second. and it's sending a digital pulse stream. So I send a write command to it, and it sends a, this sensor has a 3-axis accelerometer, and then the joystick and the 2 buttons, and it sends all of that back as a digital stream, which we then decode. Are we using the accelerometers for anything? No, thank goodness, because people get so excited they shake this up and down. Like that. All right.
Just launch your control too.
So, okay, other questions?
Just using the joystick data, that's all.
We're using the joystick and the buttons at this point. So we talked about trying to use gestures with the nunchuck, but I think just having an accelerometer, it makes it hard to have
You need
accurate
6
gestures.
axis to do that.
I think you're right.
Can these servos be controlled by a regular Arduino board?
I'm going to say that the answer to that is definitely yes, but there's a lot of front end. There's no easy sort of Dynamixel library from an Arduino board.
You need a 485.
Yeah, 485.
Yes.
I did a search actually for Arduino library for AX12.
Yes.
A lot of entries pop up. I mean, I didn't research it. but-
Yeah. So I mean, I worked on one 3 years ago, and so you can drive the TTL servos certainly with just with a native Arduino. Some of the problem this bus runs at a megabit, and doing a megabit with an Arduino requires you to be very careful, right? You're not going to do bit banging at a megabit on an Arduino. Is that fair? So to do it well requires that you think carefully about things. Not that it's impossible. And my experience with making Arduino-based Dynamixel devices, which I did, was that they were very unreliable.
Well, my question was actually related to that bicycle shifter project.
Yeah.
And one of the requests was to drive the brake.
Mhm.
And to drive the brake, we need some really strong, reliable servo.
Right.
And I'm looking at this, and it looks magnificent, you know.
Yes.
And the price is right, $45 or even $200, whatever. But I need to connect it to the Arduino remote controller.
Let's talk individually, Sergio. Okay. You also want it to be reliable. Other questions about it? Okay. Thank you guys very much.